Today, as part of this continuing video, we're going to talk about several different kinds of search engines as well as a time overview function to help you very quickly visualize and visually summarize the activity in a capture file. I'm going to use certain demo files, and we'll pull them up as each of the carrier searches or each of the search engines are viewed and demonstrated. First one we're going to talk about is the ability to correlate against the timing sequence, the correlation sequence of a standardized waveform. Each of these utilize a precursor portion of the waveform that is used for synchronization prior to the transmission of actual data. And Spectro-X can very quickly correlate against those training sequences and help you be able to identify standard carriers from carriers that you may be more concerned about. Standard wireless carriers, for example, in a laboratory environment or in a battlefield environment, are carriers that you can either control or that are at least considered perhaps friendly. And so the ability to remove what you know, or to be able to identify carriers that are harmless against carriers that are of more interest, is a very quick way of beginning to peel various layers of the onion back to reveal actually the carriers of specific interest to the design. Spectro-X gives you a very easy way of doing that by clicking on the standard search. You can see that Spectro-X allows us to be able to quickly identify GSM, Edge, several variations of 802.11 wireless LAN, and several variants of the LTE type of waveform as well. Now, the capture file that I have here that is being played is for standardized wireless carriers. To make it simple for this demonstration purposes, these are the only carriers in the file, but we'll use this as the basis for more advanced searches as we go through the process and through the demonstrations. So what I'm going to do is I'm going to tell Spectro-X to start with a carrier frequency of 5 megahertz. It could be anything that I want it to be, but you see that at least I know that I've got one carrier, what looks like to be centered right around 5 megahertz. And I'm going to tell it to go ahead and step to either side of that carrier in this case 5 megahertz increments, but I can set that to whatever value that I want, and to step over a range totaling 45 megahertz in either direction. So 45 megahertz, starting at 5 megahertz, going down 45 megahertz would take me down to minus 40 megahertz, theoretically centered over whatever this carrier is. 5 megahertz plus 45 megahertz allows me to move up in frequency and to be able to capture everything that is shown within this spectrogram and on this capture file. I'm going to tell it to look at each one of these steps. I'm going to tell it to look for the training sequence of all of these various waveforms, and I can tell it to search over the entire file by clicking on automatically choose time limits, or in this case, to make the demonstration move a little more quickly, I'm going to say look over the first millisecond worth of data and tell me what you find. And I can go ahead and click on each one of these to highlight what was found. In this case, I clicked on the one saying that the carrier frequency was minus 40 megahertz, which is this particular signal here. You can see the training sequence, which was the actual portion of the waveform that was used for the correlation, and it correctly identified it as a LTE signal. I can equally look at, for example, what it's telling me as a 802.11 signal, centered at 40 megahertz, and sure enough, it begins the display, the enhanced display of the waveform that it found, beginning with the training sequence of a 802.11 waveform. And similarly, it will go ahead and it has found LTE, GSM, Edge, as well as the wireless LAN carrier of interest. So a very quick way of being able to correlate against and discover and tabulate for you the location, start time, and the level of confidence of the correlation of standard wireless carriers. Now, that's a fairly simple example, but let's go ahead and then take this to the next level of complexity.